Today's lesson is fractions in the world, and we're going to convert rational numbers to decimals using long division, and we're going to know that the form of a decimal can terminate or repeat. We're going to do this by solving some fraction word problems, and to remind ourselves that these can also be done in terms of decimal numbers as well. You should have your word problems pasted into your notebook. So let's begin. We're going to have a couple different examples just to go over and give us a little refresher of what's been going on lately in math class. Problem number 1 says a patient is given 1 1/2 teaspoons of medicine in the morning and 2 1/4 teaspoons at night. How many teaspoons does a patient receive daily? Well, if they get 1 1/2 teaspoons in the morning and 2 1/4 teaspoons at night, we want to combine those two values and figure out how much they're getting total, correct? First things first is to change those mixed numbers into irrational numbers so that we can work with them. The first one, 1 1/2, written as an improper fraction is 3 halves, plus 2 1/4, written as an irrational number, is 9/4. And I do that by multiplying my denominator times my whole number and then adding the numerator to get the leftover components of my fraction. Now I need a common denominator in order to add fractions. I can change my denominator of a 2 into a 4 by multiplying by a whole number of 1 represented as 2/2. So when I rewrite this fraction, it's going to be 6/4 plus the original 9/4 that I have. Now I just add my numerators together. 15/4 is the total number of teaspoons of medicine that one person takes daily. If I want to put it back into mixed number form to have more of a real life scenario and be able to see the real value, I would divide 15 by 4. That can go in evenly 3 times, and I'll have left over 3/4 of a teaspoon. Problem number 2 says 3 1/3 feet are cut off of a board that is 12 1/4 feet long. How long is the remaining part of the board? Well, if I'm starting with one value and I'm taking away a component and I want to know how much is left over, this is a subtraction problem. I'm going to follow the same process I did for my addition problem. First, by putting the mixed numbers into an improper fraction. 4 times 12 is 48, plus 1 is 49/4. Minus 3 times 3 is 9, plus 1 is 10/3. So I have 49/4 minus 10/3. And these numbers need to have a common denominator, again, because we are doing subtraction problem. So I'm going to use the value 1 represented by 3/3 and represented by 4/4 in order to multiply and get a common factor. 3 times 49 is going to be equal to 147 over 3 times 4 is 12, minus 10 times 4 is 40 over 3 times 4 is 12. Now I just subtract. 147 minus 40 is 107/4. Writing this out as a mixed number again instead of, 107/12. Writing it out as a mixed number would be possible if I wanted to do my long division, figure out how many times 12 can possibly go into 100. I would say it probably is going to go about 8 or 9 times there, maybe 8. 8 times 12 is 96, so that would work. And if I take away 96 from my numerator, I'm left with 11/12. So my solution in mixed number form would be 8 11/12 feet of the board. The next question says the coffee pub has cans of coffee that weigh 3 1/4 pounds each. The pub has 8 1/2 cans of coffee left. What is the total weight of the 8 1/2 cans? So if each can weighs 3¼ pounds, but there's 8½ cans, I need my total weight. This is definitely a multiplication problem. Just as in addition and subtraction, when we do multiplication with fractions, we need to put them in an improper form. So 3 times 4 is 12, plus 1 is 13/4, times 8 times 2 is 16, plus 1 is 17/2. Multiplication and division do not need common denominators, so I can just multiply straight across. 13 times 17 equals 221 over 4 times 2 is 8. If I wanted to change that into a mixed number form, I certainly could. I can figure out how many times 8 goes into 21 evenly. When I do that, I can use some long division. 8 goes into 22 twice. 8 goes into 61 8 times. So I have a whole number here of 28 pounds of coffee, right? Whoops, I'm sorry, I made a little error. 8 goes into 61 7 times. 7 times 8 is 56, and I subtract, and I have 5/8 left over. So my answer is actually the mixed number 27 and 5/8. Sorry about that. The last problem we're going to do says Belinda baked 9 pies that weigh 20 1/4 pounds total. 20 1/4 pounds total, divided by 9 pies. How much do the pies weigh, right? This is kind of what we anticipated, is they want to know what's the weight of each individual pie. Well, let's put these numbers in an improper form. 4 times 20 is 80, plus the 1 is 81/4, divided by 9/1. I can use my bouncing ball technique here. 81 times 1 is 81, over 4 times 9 is 36. If I wanted to simplify this problem, I could divide both my numerators and my denominators by 9. 9 divided by 81 is 9, over 36 divided by 9 is 4. If I wanted to write this as a mixed number, I could as 2 1/4. So each pie weighs 2 1/4 pounds. Your proof today is to think of somewhere in the world you would need to solve a problem with fractions and explain the scenario. You don't need to solve anything, but I want you to give me kind of a story that would go with a good fraction solving problem.